Hello, everyone, and welcome to this Lattix API training. My name is Neil Langmead from the Lattix support team, and today I'm going to introduce you to the Lattix Python API. We're going to start with some use cases and then look at some examples, and then you can get further documentation and help from. So here are some use cases. If you want to programmatically interact with Lattix data, then the Python API is for you. It enables the easy integration of Lattix data with other tools, perhaps other testing tools or quality management tools, or data in the pipeline, for example, in the CI/CD pipeline in GitLab, GitHub, or Bitbucket. Perhaps you want to integrate to automate reporting, for example, of metrics, or change impact analysis, or other architectural analysis that you do with Lattix Desktop, but you now want to make this data available and socialize it with colleagues. That is another use case of the Lattix API. You can also use it for automation of tasks, such as tagging. Perhaps you want to tag everything in your dependency structure matrix that is a MISRA violation, or that is an AutoZAR violation, or that has some other property you want to see across the architecture. You can now automate the tagging of the dependency structure matrix using the Python API, and we'll have a look at an example of that too. And as I say, you can also use it for impact analysis reporting. Further, you can use the API to integrate Lattice with AI systems such as MCP, the Model Controller Protocol, or RAG, the Retrieval Augmentation Generation System, or vector database stores customized knowledge bases that you can then add to a large language model, for example. So the Python API was designed to replace the Lattix Groovy API, and you can see that in the documentation here. We have a full description of the Groovy API, and it's a like-for-like replacement. So everything that you can do with the Groovy API, you can also do with the Python API, plus a lot more. So if you go to docs.lattix.com and the scripting with Python page, you can now see how to use the API for the first time. The first point to make is that the API is only compatible with Python 3 for Unix-like or WSL, Linux-type systems, and Python 3.12 for Windows. So check your Python version before you get started with the Python API. And to set it up, we recommend that you create a virtual environment with venv using this command. And typically you give the path to your virtual environment. And then this allows access from Python to the API with the API files provided in the Lattix installation directory. These are called pyliblattix.pyi and pyliblattix.so for the shared object file that you see on Linux and Unix systems, and pyliblattix.pyd for Windows. So let's have a look at that inside VS Code. Here I'm actually running Lattix inside a dev container within VS Code. And if I just go to workspace, my Lattix directory here, and you should see a Python API, and you will see those pyliblattix files here in the installation directory. Okay, so you can use Python in the traditional way, and you could simply add this Python API directory to the Python path. That's possible, or you can add it in the configuration for your container in site packages. You could do /workspace/Lattix Python API in a pyliblattix.pth file, or a lattix.pth file as well, which specifies the location of the Python API files. Back to the slides. So we need to make sure we're using the correct version. Here is the call that we've just looked at in the documentation to create that virtual environment, to allow access to the Python API within the installation, and to start the virtual environment as well. Once you have started that, you can activate the virtual environment with source venv bin activate, or on Windows, the .venv scripts activate.bat script will also work. And as you've just seen, creating that lattix.pth directory in the site packages directory contains the path to your Lattix assembly directory. And that should be all you need to do to get set up and start using the API. So what are the key classes that are available to you? Well, there are 5. Firstly, the project model. So the project model gives you access to the entire project data, and you can see how that is used here. We have pyliblattix, acquire Lattix API call, and that is then stored in API as an object. You can then call API methods by api.openLattix project and assign the return of that invocation to the project model. So for example, here we are calling openLattix project to open a Lattix LDZ file and then store the result in project model. And then we're using the print method to print project model.project name. And we can then print the pyliblattix as well. Then a little bit further down, we are using the root partition class, the partition class here, and you can then directly invoke methods such as expand members. So you would expand members to in the DSM to expand to the lowest level, the lowest atoms, functions, and methods. And you can actually call expand members on that project model object to get the subpartitions of those members, for example. And then you can also use methods such as all high-level cycles, and interacting with VS Code, programming in VS Code gives you access to this API. So the project model is probably the most important class. Partition is also an important class because partitioning is something we do a lot of in Lattix, and now you can do that programmatically. The atom class, as its name suggests, is the atomic class with all the methods of the base atomic types. And then dependency edge, dependency class, and tag class complete the main key classes in the API. All of these are actually documented as well in docs.lattix.com scripting with Python. Here you can see the project model, which every script actually needs, connecting directly to the API object, as we've seen. The partition represents the basic element of a Lattix project that's visible in a CAD diagram or a DSM. The atom represents a basic domain element. Partitions contain one or more atoms. And then a dependency edge or dependency represents a dependency between a source and target atom. Remember that a target atom can be an external atom as well. We talked about tagging. A partition can be tagged or labeled in order to aid the analysis and selection. There's a many-to-many relationship between tags and partitions. And here we have an example script that you can use to get started to tag a named partition. Let's have a look at that inside VS Code. So I'm going to go to my VS Code. I'm just going to check my version of Python here. It's 3.12, which for Windows is the right version. And I'm just going to call the simple API method here, simpleapi.py. And all this does is connect to the open Lattix project and opens the LDZ file and prints the project name. So we can run this here in the API. Let's call this simple API here. And then that will invoke the Python interpreter applied to that script, which then connects to our LDZ file. And in this case, all is what it does is it prints out the name of the dependency structure matrix, the project name, which in this case is simply build spec. Okay, so that's our very first simple script that we can get running. And if you have that working, then your API is working. Once again, the steps are acquire the Lattix API connection, connect to the open Lattix project method, and then print the project name. What about something more sophisticated? Well, for any class, you can print the help. And this is something that's really simple to do in Python. We just call help on the actual class method. And I've called it on the project model. And I've also called it on the add atom to partition. And it's going to give me information and help about the project. And then it's also going to save the project just to show you how to save a particular project. So I'm going to do Python 3 help Lattix API now. And now you can see it's going to print out those helper tools for us. And it's going to give us the API parameters, the arguments that we need. And it's going to give us all of those methods that are available in the class, including the C++ signature. And I'm just going to go through all of those. And you can see the entire stack trace is printed and every API is listed. And this is on the add atom to partition method here that you can see too. So that's a bit more sophisticated example. How about a demo report? Okay, so here I'm going to create a connection to the LDZ file, and I'm going to do something a little bit more sophisticated, and I'm going to get the root partition and then expand all members of this partition. And I'm going to call the all high-level cycles method, and I'm going to print all of the metrics that are available to me. And this is going to go through and loop through all of the metrics and print those metrics for me. This is ideal then for building a separate report, for example, or querying the Lattix database, the Lattix project file, getting those metrics values and passing them on to some other report or generating a custom report. Okay, so let's run this one, Python 3, and this is the demo report.py. Now this is going to loop through all of those metrics and the names of those metrics, and we will see, for example, complexity, stability, connectedness, all of the metrics that Lattix provides, together with the values for this particular dependency structure matrix. Okay, so here are some example scripts. We've seen a demo report, we've seen a simple API invocation. We also have a simple script that will tag a DSM with your favorite tag. So here we are calling the create or find tag red invocation and creating something called my tag name. And what this will do is we'll open the LDZ file and it will create this tag for us. So I'm just going to run this tag, and then we'll have a look in the DSM to see what that looks like in the DSM. We should see a new tag called my tag name, and it should be applied to, if you see here, I've got a partition called utilfuncs, utilfuncs.cpp, and then this method is going to add that tag to the partition, or the other way around, is going to add the partition to the tag. So what I expect to see when I open the DSM is that my tag name has been added automatically to the utilfuncs partition. So let's have a look at Lattix and just see if that did indeed happen. Here we have my tag name, and here we can see that it's been added to ISO glib and the project here. And now you can see I have a red tag. Go to here, and we have this tag called my tag name that's been applied to utilfuncs.cpp. Okay, so this is a simple example of adding a tag using the Python API script. Okay, so just to recap, we have the project model. This function will allow you to access the Lattix project saved in the specified LDZ file. And then the project model has a partition representing the basic element of a Lattix project visible in the DSM CAD. The atom is representing a basic domain element containing more or more atoms. Dependency edge and dependency represents a dependency between a source and a target atom, which could be external. And as we've just seen, partition could be tagged to aid analysis and selection in a many-to-many relationship between tags and partitions. Here's that script that we've just seen, my tag name. This is also provided in the documentation. And that concludes this short Lattix API training. I hope you found this useful. Do check both the examples that are provided with Lattix, which we can furnish you with, but also our documentation on docs.lattix.com for more information as we continually add new functionality to the Python API. Stand by and watch out for updates. Thank you for listening. Do not hesitate to reach out to us if you have any questions about the Python API. And we were excited to see what you build with the Lattix Python API as well as you integrate Lattix into your own systems and come up with your own use cases. Thank you very much.